Hello, welcome back. We got Module 3. Module 3 introduces geometry, and in geometry, you got units. So, Section 1 talking about all about measurements and units. I would say this first piece is very, very similar to a thing you may have done in chemistry class called dimensional analysis. So, if this looks eerily familiar to that, that's something good to Google to make sure you get extra help with that. I need more space. I don't know why I organized this thing so close together because with dimensional analysis, all you're really doing is you're starting off in some type of units and you're ending up in another type of units. Now, these are interesting because they don't give you like the actual, oh, my bad, Siri. They don't give you like an actual number. They want just a setup. I've seen it both ways. This is weirder to do, so I want to show that one. All right. High-speed train travels at 180 kilometers per hour, which setup is equivalent to the speed in meters per second. So a couple things here with this. I personally love to show where am I starting off at and where am I ending at. Now, I don't really know where I'm ending at, like physically on the paper, so I'll just put it here. I want to end up at having meters per, that's a fraction part, second. I currently have kilometers per hour. The idea behind the dimensional analysis is this, is if you have the same thing on top and bottom of a fraction, for example, this is not what we're about to do. We are a little bit. If you have some form of kilometers on bottom, these units would cancel. We convert kilometers to some other unit. So let's say that it's going to be meters. Therefore, if I was to cancel out these kilometers, I'm now left with the measurement in meters. Same idea here for hours. If I was to convert hours to minutes, to seconds, to whatever, I would want to put the hours on top because the top of the fraction cancels out with the bottom. And then what I want to convert it to on bottom. Maybe it's like days or something like that. Maybe it's minutes. Maybe it's hours. Maybe it's seconds, Whatever is left over is your new measurements. So in the end, I want to end up with just the meters on top and just a seconds on bottom. So let's kind of see what they give me. Starting off, they gave me kilometers per hour. And more specifically, they gave me 180 kilometers per 1 hour. We want to end up in meters per second. Now, do notice they give you some helpful information. 1 kilometer is 1,000. 1 hour is 3,600 seconds. So if we want to cancel out the kilometers on top, we got to put it on bottom next. We want to end up with meters, so we'll put it over meters. So now, by definition, 1 kilometer is 1,000 meters. Great. What this means is in a little bit, when I start to multiply these fractions out, your kilometers would cancel out. Great. My answer currently is going to be meters over hours, but I don't like that hours on bottom. So let's get rid of the hours. What do we know? Well, if you want to cancel hours and you want to end up with seconds on bottom, 1 hour, by definition, is equivalent to 3,600 seconds. Now, if we were to cancel out, hours is left on bottom, hours is on top, therefore those would cancel. And notice in our fraction, the only units left over are meters and seconds. Now, with fractions, what you are doing is you are multiplying straight across. So in your new numerator, it's 180 times 1,000 meters. And on bottom, really also times 1, but that does nothing. On bottom, it's 1 times 3,600. So I'm just going to write it as 3,600 seconds. And in this case, looks like it would match up with answer option A. Now, dimensional analysis looks very different as well when you kind of get this stuff with cubes and squares. But the idea is still pretty much the same. What are you canceling out? What are you left over with? All that fun stuff. All right, number 2. Delivery truck has a capacity of 15 cubic meters. which expression calculates the capacity in cubic centimeters. So thankfully, we're working with just one unit now. And you're starting off, this is interesting. We're starting off with cubic meters. Now, that's not typically an issue. The only weird thing is they give you the information in just regular meters and centimeters. So in a little bit, we got to do some conversions, okay? And honestly, we can probably do the conversion right now. So a cubic meter is just literally a meter to the third power. So if I have 1 meter is 100 centimeters, that means a cubic meter is 100 centimeters cubed. Why is that helpful? Well, let's do your conversion. We're starting off with 15 cubic meters, and you want to end up with, what is in this case, centimeters. That means the cubic meters need to be on bottom. The cubic centimeters want to be on top. So we just said 1 cubic meter is equal to, and I'm probably do it like this, 100 cubic centimeters. Good news, meters cancel. Good news, centimeters left over. Even better news, multiply the fractions. You only have 15 times 100 cubed on top, because on bottom is just a 1, and that can just go away altogether. Which leads us to, okay, well, they probably want us to work out, actually have it right here. I don't think that's going to, yeah, okay, cool. I'll try to make sure. Okay, cool. All right, number 3, last for your conversion part. The other ones are kind of conversion as well. Density of wood is 0.8 grams per cubic centimeter, which calculation represents the conversion to kilograms per cubic meter. Man, so 1 kilogram is 1,000 grams. 1 cubic meter is 1,000,000 cubic centimeters. Ooh, so this is interesting because what you start off with is just regular grams. I'll put GM. And cubic centimeters. And you want to end up with kilograms, regular kilograms, and cubic meters. So they want us to do some cubes and some not. So that'd be interesting. All right, let's start it. Let's work on your grams first. I don't want grams anymore. I want to get rid of those. And I want to replace those grams with kilograms. What did they tell us? Well, we know that 1 kilogram is 1,000 grams. Therefore, they use just a G. I don't know why I put in GM. That's weird. Cool. That means 1,000 grams is 1 kilogram. That's great news because now grams cancel out and you're left with just a kilogram on top, which we love and which is what we wanted. Now, do notice, thankfully in this case, this is something not like number 2, right? Number 2, they gave you the meter in centimeters and you have to actually cube it. Thankfully now, they're giving you just the actual cubic meters and the cubic centimeters. So here, if you want to get rid of this cubic centimeters, that means with your new fraction, we need cubic centimeters on top. And you want to end up with cubic meters. So let's put the cubic meters on bottom. And they tell us that 1 cubic meter is 1,000,000 cubic centimeters. So 1 cubic meter is a milli. Wow, that's very cramped. I'm missing a 0 there. Is 1,000,000 cubic centimeters. Better news, centimeters cancel. You're left with just a kilogram over a meter cubed, which we can line it up now as the top of the fraction, 0.8 times 1 times, 1,000,000. 0.8 times 1,000,000. On bottom, we have, my bad, forgot units. I apologize. We have what? Kilograms. Cool. On bottom, we have just, 1 centimeter, 1,000 grams, 1 meter cubed, but those other units cancel, so just 1,000 meters cubed. And so now let's try to match it up. Ooh, these are interesting. You can kind of also see like the fractions, like this should be 1 over 1,000. So it's one of these two. The last one should be 1,000,000 over 1. So it kind of has to be B in this case. So very interesting question type. Very, very similar here with skill drawings. I would say I'm going to approach it a different way instead of dimensional analysis, maybe a little bit easier. In theory, what I'm going to do here, you can do here. It's just kind of weirder to do, especially because you're going to have like two separate units here, and you want to end up with two separate units. Whereas here, you typically want to end up with just one unit. Okay, we have a scale that is 1 inch equals 5 feet. A room has an area of 20 square inches on a blueprint. What is the area of the room in square feet? So kind of like we did earlier, let's start off with what we know. We know 1 inch is equal to 5 feet. We want to end up with the area in square feet. Well, it would help if we know the area in square inches, because then we can kind of work from there. Well, let's go ahead and start that off. We need to end up with square inches and square feet mainly. So let's go ahead and do that part. To get square inches and square feet, we literally just square it. So 1 squared is just 1. Inches squared is just inches squared. 5 squared is 25 feet squared. So this is kind of like similar to our proportion stuff. You want to end up figuring out what is the square feet, and you know there are 20 square inches. So very similar to our proportions. It's almost as if this is a unit rate. You start off at 1. Oh, my bad. You start off at 1, end up at 20. So 1 times something gets you 20. Well, 1 times 20 gets you 20. Therefore, it should scale up with that same unit rate or that same proportion. So 25 times 20 would be, in this case, 500. On our map, we drew it as 20 inches squared for the area. In reality, the actual area of the room is 500 square feet. Similar vibes with all the other ones, especially if you haven't tried it already. Take a second, right? City Planner uses a map with a scale of 1 centimeter. I'm going to start it off there. 1 centimeter equals 4 kilometers. A park is drawn as a rectangle with an area of 6 square centimeters. What is the area in square kilometers? We need that squared. So let me go ahead and do that part real quick. So squared, 1 kilometer squared equals 16 kilometers squared. Okay, we have an area of 6 kilometers squared. What is the area? Sorry, we have an area 6 centimeters squared. What is the area in kilometers squared? Well, you start off with 1 and you got to 6. So clearly you multiply by 6. Same thing. If you multiply one side by 6, multiply the other side by 6, which would get you 96 in this case. Last one. Same thing with the map, but now you have a triangle forest reserve. 1 inch is equal to 10 miles. We want to end up in square inches and square miles. So let's go ahead and do that squaring part. Oh, there we go. So 1 inches squared equals 100 miles squared. You have 4.5 inches, and you want to end up in square miles. Therefore, if you multiplied one side by 4.5, you gotta multiply the other side by 4.5. 100 times 4.5 is 450. So conversion of units, very, very, very similar to chemistry, dimensional analysis, and then also some scaling up and scaling down, very similar to our first unit about proportions and unit rates. As always, if you have any questions, because this is a weirder one, definitely let me know. Send me an email, put it in the comment section down below. If not, thank you so much for watching. Hope you have a great rest of your day. And as always, go Mavericks.